Hey everybody, today we're going to be going over the very last section of Unit 7, and this is regarding parts of similar triangles. This note document is going to be found in the Google Classroom, so if you want to print that out and follow along, that's great. And here's the target we're shooting for. So by the end of the lesson, you will recognize and use proportional relationships of corresponding angles, bisectors, altitudes, and medians of similar triangles. Now this median term is not the median you're thinking of. It's a different one. It's not the median you're looking for. And also being able to use a triangle bisector theorem, which we've actually already used in a previous section just because I threw it in there, but yeah, we'll get to it. Anyway, all right, let's get through the first of the theorems. So the special segments of similar triangles. If two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So in other words, we know if triangles are similar, the sides have a proportional relationship. Well, so too do the altitudes. The altitude is literally the height. The height is not, well, okay, let me put it this way. The height doesn't need to, or the altitude doesn't need to be part of the triangle itself. It's actually something that measures the distance from the base to the highest point of the vertex of the two sides. I'm explaining in a really terrible way. You'll see what I mean. So, all right. So abbreviation triangle, okay, yeah, so this would be the altitude. AD would be the altitude of triangle ACB, and the altitude of triangle FHG would be FJ. So here's the altitude, here's the altitude. So let's go ahead and show what I'm talking about. So we're going to go blue over red. So blue over red. So we're going to go AD over FJ. And we're going to go blue over red. So AC over FH. So this isn't really too much of a stretch. It's just saying that the altitudes will have the same relationship that the sides do when the triangles are similar. So identify the similar triangles and then find the value. Okay, so, all right, so we're going to say ABC. So triangle ABC is similar to triangle FGH. All right. Hold on a second. This is getting in the way here. There we go. All right. All right. So here's the altitudes. We're going to go BD over GJ is equal to AB over FG. And then let me zoom in here a little bit so you can see a little better. Okay, and we're going to solve. So let's plug these values in. So BD is 9, GJ is 6. Oh, sorry, we should do blue over red as well. So blue over red, and that's what this is. And then blue over red. So we're going to have, say, 21 over FG is X. Okay. We can simplify this. This will become, we'll divide these both by 3 and get 3 over 2. Okay, and then we're going to cross multiply here. So we're going to get 3x equals 42. And we're going to divide both sides by the coefficient. And we're going to have x is equal to, what is it, 14? So 3 divides 4 once. Remainder 1, 12, yep, 14. X is 14. So we identified the similar triangles and we found the value of x. Okay, cool. So this isn't really different. This is just using what we already know, but with altitudes. All right, here we go. Okay. So if two triangles are similar, the lengths of the corresponding angle bisectors, interesting, are proportional to the lengths of corresponding sides. Okay, so an angle bisector is a special segment that cuts an angle in half. So as you can see here, this is an angle bisector because it creates two congruent angles. Same thing here. So these lengths will have the same proportional relationship as do the sides of similar triangles. So let's be more specific instead of me blabbing. So blue over red. So we're going to say LP over RT. Okay, is equal to, and we're going to go with I don't know, LM over RS. So LM over RS. Okay, and then we're going to go ahead and solve. Oh, we can't solve. That's just an example. Yeah, but you could do that with any of the three sides along with the angle bisector. So this is actually what we did earlier. Well, it's similar to it. All right, so this is the angle bisector. So that angle bisector, and this is an angle bisector. So x over 8. And if you haven't gotten some different colored pencils or pens, I would definitely recommend it because it makes these a heck of a lot easier. So blue over red. So we're going to go 15 over 12. Okay, and then we're going to cross multiply. So I'll simplify that first. So divide these both by 3. We're going to get x over 8 equals, what, 5 over 4? And I bet this is going to be 10, because look, this is double that, this is double that. Yeah, I bet that's 10. Let's find out. 4x equals 40. Oh, look at that. X is going to be equal to 10. There we go. X is equal to 10. There we go. All right, pretty straightforward. All right, and here we go. If two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. So before I continue, median, okay, a median is a line segment that starts at a vertex of a triangle, okay, it goes to the opposite side, and it cuts that side in half. So it creates two congruent sides. So median, again, it starts at a vertex of a triangle, like so. It connects to the opposite side of the triangle, and it creates two congruent segments. It basically cuts those in half. So median and mid-segment get confused. We're going to get to mid-segment later when we talk about special segments. This is also a special segment, but we're not going to. I'm pretty sure mid-segments don't pop up. But yeah, median, you start at a vertex, and you connect to the opposite side of a triangle, and it creates two congruent sides. All right. So anyway, the lengths of the medians also have the same relationship. So this is really just saying that all these special segments that we're talking about so far have the same relationship as the sides. That's the gist of this section. So DC over YZ equals, and we can pick either one. Let's go with AC. AC over WY. AC over WY. There you go. All right, here we're going to go our mid-segment. Our mid-segment, which is median. I shouldn't have said it out loud. Look, now that I said it, it's in my head. Our medians, rather, sorry. So 12 over 8. We did our medians. Now we're going to go ahead and take this special segment. And that's not the side, though. This is the side. And this is the side. I almost got caught there. All right, so we know that if this is 5, this is going to be 5. If this is x, this is x. So, yeah, okay. So 12 over 8 is going to be equal to, this is going to be 10, and this is going to be 2x. And let's go ahead and cross multiply. Actually, before I cross multiply, let's simplify that to divide those both by 4. So 3 over 2. And I could divide those both by 2, actually. Let's do that. Let's make that one x over 5. Yeah, you can do that. And then we're going to cross multiply. We're going to get 7.5. I don't know if this is right, but we're going to check. Make sure I didn't screw this up. I feel like I might have 2x. And divide by 2. And we get x equals 7.5. I'm going to pause for 1 second, make sure I didn't screw this up, guys. I just have a feeling. Hold on. Be right back. Okay, I did not screw it up. Yeah. So you don't want to fall in the trap of using the, you do not want to use that relationship there. But anyway, yeah, so that worked. Cool. I just thought I messed up for some reason. All right, never hurts to check. All right, let's see what's here. Triangle, angle, bisector. If an angle bisector in a triangle separates the opposite side of two segments. Oh, interesting. Okay, so let's read this again. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. Okay, interesting. So this is actually what appeared in the exercises we did previously. This is the name for it, triangle angle bisector. It's a fairly obscure theorem that very rarely gets used, and I honestly forgot the exact definition of it, so I had to look it up just to remind myself. Whatever. So basically we're saying that this angle bisector effectively creates proportional relationships between these two mini triangles. So blue over red, which is going to be Km over JK, just kidding, is going to be equal to ML, which is blue, over JL, which is red. ML over JL. There we go. Okay, let's go ahead and solve this though. So find the value of x. We have two examples. So blue over red. So we're going to have x over 15 equals blue over red, which is 6 over 9. We're going to simplify that to 2/3 because we divide those both by 3. So x over 15 equals 2/3. We're going to cross multiply. 3x equals 30. And we're going to divide by 3. X equals 10. Okay. And let's try this one over here. So we're going to go blue over red. So that's going to be x over 6 equals, and then blue over red. Now this one's interesting because let's say the whole thing is 18, so that means this would be 18 minus x. That's what that would have to be. So 18 minus x over 14, cross multiply. We're going to get 14x and 6 parentheses 18 minus x. We're going to distribute that 6. Okay, we're going to get 14x equals, what's 6 times 18? Let's see. Oh, why did you divide? That's not what we're looking for. 6 times 18. There we go. 108. So 108 minus 6x. And let's get the x's on the same sides. We're going to add 6x to both sides. And we're going to get 20x. This is an interesting problem. We're going to get a remainder here, which is fine. So divide that by 20. This just seems like, did I screw that up? I don't think I did. Let's see, x over 6. No, I didn't screw that up, so I don't know. It's a weird problem. All right, we're going to divide that. So 108 divided by 20. We're going to get 5 4/10. So x is 5 4/10. And that's it. All right, last example here. And we're gonna skip that. No, we're gonna keep that one. That's an interesting one. Sanjay's arm is about 9 times longer. Where's his arm? I don't know. Sanjay's arm is about 9 times longer than the distance between his eyes. Okay. He sights a statue across the park that is 10 feet wide. All right. If the statue appears to move 4 widths when he switches eyes, so 4 times his eyes, I imagine, estimate the distance from Sanjay's thumb to the statue. Okay, that's quite interesting. So this is the length between the eyes, AB. Okay. And it's saying that the distance, the arm is 9 times longer than that. Okay. I'm having a hard time figuring out what, there's the thumb, so here's the arm. So if this is x, if this is x, this is 9x. So PC is equal to 9 times AB. That's what we know. Okay. He cites a statue that's across the park that's 10 feet wide. So this is 10 feet. So DF equals 10 feet. Full disclosure, we may stop in the middle of this if this problem continues to be really confusing. We'll find out. If the statue appears to move 4 widths when he switches eyes, so when it goes here, each of these means 4 widths. Okay, interesting. Estimate the distance. Yeah, you know what? We're going to cancel that. Don't really feel like doing that. We'll do that one in class, actually. That's one that's going to be much better with with questions and answers, but more so because of the way it's written. I understand what they're trying to do here, but yeah, we'll do that together. Anyway, all right, so that's basically it. So the main thing, the really big takeaway is this. We need to have a takeaway of the altitudes, the angle bisectors, and the medians. Those three things have the same proportionate relationship as do the sides of similar triangles. Also, when you have an triangle angle bisector, it creates two little similar triangles inside of it. That's the big takeaway. All right, and that's going to be it for the unit. So if you got this, you're in a really good spot, and we're going to start reviewing for the test on Monday, and the test will be given Tuesday. All right, see you guys soon.